Hi, my name is Kian, and today I wanted to discuss the concept of tetrode recording. Typically, when people record from single electrodes, assuming that this is an electrode, you could have multiple neurons within the recording radius of this one electrode. And the signal picked up by these three neurons may or may not look different on the recording electrode. If the shape isn't very different or the amplitude isn't very different, then you may not be able to tell which waveform came from which neuron, which means that you won't be able to spike sort very easily. This may not be a problem in areas of the brain that the neuronal density is not very high, because you may have one neuron or maybe two neurons and the shape could be different. But when recording from an area of the cortex where the density is very high, you may have 10 neurons within the recording radius of this electrode. You need a better way to be able to distinguish between these different neurons. And what people use is basically multiple electrodes very closely spaced. So it could be multiple electrodes twisted, so microwires that are twisted. So you'll end up with 4 electrodes at the tip that are very closely placed. Or you may have a single electrode shank with multiple electrodes printed very close to each other on this one shank. So an example of this would be the laminar probes in the tetrode configuration. And the tetrode configuration basically means the 4 electrodes are very close to each other, so they more or less record the same neurons. And what happens is that if you have these 4 electrodes and you have multiple neurons, when this neuron fires, this is closer to this electrode, so you'll get a higher waveform, a larger waveform on this electrode than this one. So larger waveform on this electrode, medium waveform on these, and lower on this one, versus when this other neuron fires, then you get a large waveform on this electrode, medium waveform on this one, and small on that one. So all of them record the same waveform at the same time. And that way, when you feed the data into the spike sorting software, the spike sorting software will use a triangulation algorithm to determine which waveform belongs to which neuron. The same waveform gets recorded by all 4 of them, and then you'll be able to distinguish between them. So that's one technique that they use in recording from high density areas of the cortex, such as the hippocampus, and it really helps with spike sorting of these neurons.